This is a video reviewing how to run a one-way repeated measures Anova, and this is a good way to compare three different groups that are related somehow. So if you think back to the one-way between subjects Anova, you couldn't have any overlap between the different groups or the different levels that you had within your independent variable or your factor. Here, you still have one independent variable. You have multiple levels within that variable, but oftentimes those three will differ over time. So this will be the same person, for instance, over three different time points. If you have a match design where you have paired certain people together, you might also have those three different scores for those pairings. So that's how the repeated measures Anova differs from the between subjects Anova that we talked about in the other video. Most likely in our stats course, you'll see a repeated measures Anova differ based on time. So again, time is a key factor. Alright, so here we have an example with variables named T1, T2, and T3. To get more information on these variables, you can click down here on Variable View, down in the bottom left-hand part of your screen, and you'll see that T1, T2, and T3 stand for the initial, second, and final depression scores, respectively. So this comes from a study where therapy is used to measure depression or to treat depression, and a therapist is checking to see if people's scores are going up, going down, what might be happening. So to run the actual Anova, you'll click on Analyze, General Linear Model, and then you'll go over to Repeated Measures, and you'll get a box that looks like this. So this says Repeated Measures Define Factors. We have to tell SPSS how many levels we have and which variables will go into those levels. So we can name our within subjects factor anything that we want it to be. So for this example, let's use time. And we've got three different levels. We've got time 1, time 2, and time 3. So we'll add that, and then we'll click Define. And you should get a box that looks like this, where you've got spaces for three different levels, and we can just take all three of the ones that we have in our set and move them over to this box. Just like before, we can take options and then click estimated marginal means for all of them. We'll go to compare mean effects, Bonferroni, and then descriptive statistics and estimates of effect size. Down here we can change this if we need to. For instance, if we need a 99% confidence interval or any other value that's told to us in the problem. We'll click Continue, and we should be good to go. Let's click OK. So you'll get an output that looks like this, and then let's extend this over. Oops. And so you'll see here that there are different boxes for two different types of effects, within subjects effects and between subjects effects. Since we are looking at a repeated measures Anova, we will look at the within subjects effects box this time, okay? Because again, we're looking at something changing over time, and that is within subjects aspect. So here we have time, which is what we're looking at, and for our purposes, we're using the sphericity assumed box, and we see that this number, this significance level, is less than 0.05, so it is significant. So the way that we would pull information from this is we would write F, our F statistic. We would use the degrees of freedom for time and then for error. So F parenthesis 2, 110 close parenthesis equals 534.19, and then our p-value is less than 0.001. We also have our partial eta squared for our effect size, so we can go ahead and report that as well. So that's what we would report for the repeated measures ANOVA. Now we also need to see how those three different levels differ. So we'll go down to pairwise comparisons, this box, and we have the means reported here. So we see that at time 1 there was an average of about 18, a score of 18 on the depression scale. So that's high. We have at time 2 an 11, about an 11, and then at time 3 we have about a 7.9 and 8. All right. So even though these numbers differ numerically, we need to double check and make sure that we have statistically significant differences here. So let's compare time 1 to time 2. There is a significant difference between time 1 and time 2, meaning that time 2 is significantly lower than time 1. So between the first measure and the second measure of depression, pupil scores did go down significantly. Let's compare time 1 and time 3. So there is a significant difference there. So this about an 8 is significantly lower than this 18. All right? And if we compare 2 and 3, we also see a significant difference there. So this 8 is is actually significantly lower than this 11.21. So what this tells us, since all of these are significant across the board, depression scores went down across time. All right, so this again is a one-way repeated measures ANOVA. One way, given that we only have one factor of time here. It's repeated measures because it is over time, and that is a within subjects factor. And we would look at the within subjects effects in order to report our results.